Thanks for watching, and here is some more practice with the factoring method. In particular, let's try to solve the following wave-like equation: 3uxx plus 10uxt plus 3utt equals 0. And all this is based on is a factorization of this quadratic, because note, so 3x squared plus 10xt plus 3t squared. You can factor this, for instance, using the quadratic formula, and you get x plus 3t and then 3x plus t. And you can check that this actually works out. And in particular, we can use this factorization to factor out this PDE. So step 1, well, 3uxx plus 10uxt plus 3utt. Notice you can factor this out as 3 times partial over partial x squared plus 10 partial over partial x partial over partial t plus 3 partial over partial t squared of u, which now we can just factor out as follows. So that's the same thing as partial over partial x plus 3 partial over partial t, and then 3 partial over partial x plus partial over partial tu. And remember, all of this is equal to 0. And so what we want to do, we want to proceed in 2 steps. So first of all, that inside thing, we call it V. C'est la vie. And then what we end up getting is a first order PDE. And so let's look again at the PDE. So if you let V to be 3 partial over partial x plus partial over partial tu, so in other words, 3ux plus ut, then our PDE simply becomes partial over partial x plus 3 partial over partial t u, v equals 0, because again, this applied to v equals 0, and so we get vx plus 3 vt equals 0, which you can either solve directly or recognize this as a transport equation. So this is vt plus 1/3 vx equals 0. And so what is the solution equal to here? Well, v of xt in this case is any function of x minus 1/3 t. Now, it's not very pretty because it has fractions, but I would like to remind you that if f is arbitrary, or if f of x is arbitrary, then so is f of 3x. So in fact, what we can have is v of xt is f of 3 times that, 3 times x minus 1/3 t for a possibly different f, and so v of xt is f of 3x minus t. Which again, I know we can just get this directly, but I wanted to illustrate the scaling property because it's important to understand. Okay, very good. So we found our v, and now we just need to find u. Okay, and now I would like to remind you, what have we found so far? We found an expression for v, and also we wrote v in terms of u. And so for the last step, we need to solve for u. But notice now we have an inhomogeneous first order PDE for u because we have ut plus 3ux, which is v, which is really f of 3x minus t. And to solve this inhomogeneous PDE, you first find a homogeneous solution. So we have ut plus 3ux equals 0, which now is a legit transport equation. So u0, so the homogeneous solution, is some function capital G of x minus 3t. Because we shifted 3 units to the right. And now for the particular solution, we need to find one solution of the equation. So ut plus 3ux equals f of 3x minus t. And now, just like for undetermined coefficients, what we want to do, we want to guess our particular solution to be of the same form as the right-hand side. So guess up of xt, up to be h of 3x minus t for some h, which is some function of s. And let's plug this in and see what we get. So what we have is ut plus 3ux is f of 3x minus t. And now let's plug in u equals h of 3x minus t. So h of 3x minus t with respect to t plus 3h of 3x minus t with respect to x is f of 3x minus t. And let's apply the chain rule here. So this is derivative of h, so h prime of 3x minus t times derivative of 3x minus t with respect to t, so minus 1, and then plus same spiel, h prime of 3x minus t times 3, and that is f of 3x minus t. And so combining, here we have 9, we have minus 1, so 8h prime of 3x minus t is f of 3x minus t. And essentially, so this variable is arbitrary, so we get 8h prime of s is f of s, so h prime of s is 1/8 f of s, and so h, the function h, is just 1/8 times capital F of s. Which is good because we found our function h, and now in particular, no pun intended, we found our particular solution. So once again, up of xt, I believe that was h of 3x minus t, and we end up getting 1/8 f of 3x minus t. And so in the end, we finally have our solution. So I think step 4 maybe, or 3. So u of xt was the homogeneous solution plus the particular solution. So it was g of x minus 3t because of the transferred equation, and then 1/8 f of 3x minus t. But here's the thing, so capital G is arbitrary, and little f is arbitrary, and so is capital F. So this 1/8 actually just gets absorbed in this capital F. And so in the end, we do have our solution, u, which is f of 3x minus t plus g of x minus 3t. Which, in my opinion, is quite beautiful. Because it's still sort of a wave-like equation. Which again illustrates the power of this method, because we can use the same method to solve equations that aren't exactly the wave equation, which is kind of cool. Alright, I hope you like this. If you want to see more math, please make sure to subscribe to my channel. Thank you very much.